computer or the calculator to do the problems rather than calculating them out the long way. So what we're going to do, if you have a graphing calculator, the video in the book will show you how to do it. I don't have a graphing calculator, so I don't know the steps, but since we have our TIs here in class, I can show you how to do it on this. It's going to be very similar to entering a probability on the calculator. The first step is to enter the n number. Okay, so remember we have NCR, right? So we're going to enter the n number. Number 2 is to hit the probability button, which is right here. And then you choose option 2, which is the NCR. And then you enter the R number, and then press enter. Okay, so if, okay, so 10C6, whoops, I'm doing that backwards. 10 is little, C is big, 6 is little. So I'm going to enter 10. I'm going to press probability. I'm going to choose 2, which is NCR. I'm going to enter 6, and then I'm going to press enter. And when I do that, I get 210. Not too bad. Okay. Jim has 4 vacation days he has to use before the end of the year. There are 26 business days left. How many ways can he use his paid vacation days? We have 26 days. He's going to use 4 of them. So I'm going to enter 26, press probability, choose NCR, enter 4. So there are 14,950 different ways he could use his 4 days of vacation that he has left. I doubt he will take into consideration all of them. Kathy has radishes and she needs 8. And how many different ways can she pick 8 radishes out of the 35 she has in her garden? So I'm going to enter that into the This is actually kind of insane, but there are 23 million different possible ways she could pick these 8 radishes. We're going to make a mixed CD. We're going back in time. We might as well just make a mixtape at this point. Okay. We're going to put 20 rock songs and 20 rap songs, or we have 20 rock songs and 20 rap songs. That's all we own because this is before MP3 players. And we're going to put 12 rock and 7 rap on the CD. So I have 20 C12 for rock, and I have 20 C7 for rap. So there are 125,970 different combinations of the rock songs. And there are 77,520 different possibilities for the rap songs. And for both, to make the actual tape, guys, shh. Okay, so we take both, we multiply them together. So I'm going to do 125,970 times 77,520, and I'm going to get oops, wait, hold on. 94. I put a comma. I think I got it. 400, 194, 651. Okay, 97,651,194,400 different mixed CDs you could make with these 40 songs. Picking 7 rap and 12 rock. Conditional probabilities we've talked about when we had dependent events, where the probability of the second event is affected by the probability of the first event. So this is known as conditional probability. We're working with 2 events or more, 2 or more events. And we've done this before with cards. Okay, conditional probability, the second event is affected by the first event. That's condition, that's the condition. So when we did this with cards, the first king, we're going to take 1 out of 13. That's our first king. We have 1 king, and we're going to have him out of 13. Then there's second king, there's 3 left. And there's 51 cards left. Now I know this is a little different than what we were doing before, where we were doing 1 out of 52 and then 1 out of 51. Remember that from probabilities? This is a little different than that because we're saying we're getting the first king. 1 out of 13 is our actual, I guess I should do this. This was 4 out of 52, sorry. 3 out of 51. Yeah, what you have left. So you have 4 kings out of 52 total cards, so there's 1 out of 13 for the kings. Then there's 3 kings left in the deck, but there's only 51 cards left, right? Because we took 1 out already. So this is our probability of getting the second king. And the probability of getting 2 kings in a row, we multiply those together, and we get 1 over 221. So to put that in terms of percentages, in case you're wondering what is the percentage of pulling out 2 kings in a row from a deck of cards, you have 0.5% chance of that happening. If we want to calculate the probability, let's say we've done the first card, we got that first card. Okay, we've got our king. And we want to know what is the probability of us getting that second king. Okay, we don't want to know the probability of the 2 kings. We already know we've got the first one. We're trying to calculate the probability of the second event. This is the probability of both events. Okay, the 2 kings starting from scratch. But we want to know the probability of, like, I've already got this first king. What are my chances of getting that second one? Okay, this is the formula for that. And so this is the calculation that we just did. This is the probability of both. Divide it by the probability of the first. And that gives you the probability of the second. So in this case with our kings, the probability of both was 1 over 221. And we're going to divide that by 1 over 13. That's okay, you just copy, copy, actual copy, dot, flip. Why? When we reduce this, we have a 1 in 17 chance of getting that second king. By percentages, it is a 5.9% chance of getting that second king if you've got the first king. It's better than it was last time, but last time you were starting from scratch. You were looking at a deck of 52 cards, right? You hadn't picked any cards out, and you were trying to get 2 kings. This time, your probability on getting the second king increased because you already have the first one in your hand. Does that make sense? So you're halfway there. So the probability of getting that second one went up. No, it's still like 6%. It's not fantastic, but it's better than 0.5%. You know. You can't remember this formula. This means and then, or followed by. Okay, so the probability of the first event followed by the second event is the probability of both first and second divided by the probability of the first. Okay. So we kind of have to calculate both things. We have to calculate the and then we have to take the first and divide it. Okay, you are playing a game of cards where the winner is determined when a player gets 2 cards of the same suit. So it doesn't matter what cards you get as long as their color, their suit matches. So you draw a card and get a club. What is the probability that your second card will also be a club? Okay, so the first club, there were 13 of them, right? 13 clubs in a deck. So there's 1 out of 4. But for the second club, we already got 1. So there's 12 over 51, which reduces to 4 over 17. So far okay? Excuse me. Now the probability of the 2 clubs is 1/4 times 4 over 17, and beautiful thing just happened here. Those cancel. So I didn't even have to think. I just write down 1 over 17. Okay? Now the probability of club followed by club, when I already have the first one, is that 1/17, right? Because it's the 2 events divided by the first event. So it's divided by 1/4. So that's 1/17 times 4 over 1. So 4/17. Which, in case you wanted to know, is about 23.5%. Game, you get a black ace. First person to get a black ace wins the game. You got your first card, and it was a queen. We want to know the first black ace and then the second black ace, because we are trying for a black ace. Hold on, I'm lying. We already have the first card. We have a queen. The first event was a queen, so the probability of a queen was 4 out of 52, which gave us a 1 in 13 chance of getting that queen, right? We want a black ace now. Two. Spades and clubs. So there's 2 black aces, but there's 51 cards left, right? This won't reduce, so we have to leave it like that. So the probability of both was 113 times 2 over 51, which is 2 over 663, which won't reduce. And so the probability of getting the black ace on that second draw is our both divided by the first. So 2 over 663 times 13 over 1. And 13 happens to go into 663 51 times, in case you guys had your 13s memorized. I figured you did. So you have a 2 in 51 chance, which if you looked at that percentage-wise, it is a 3.9% chance of that occurring. And the reason that one's low is because there's only 2 of them in the whole deck, right? So that reduces it down a little. I am going to draw a tree diagram quickly. Okay, so Sandra goes out for her daily run and she goes down a path that has alternate routes to give her a variety of choices to make her run more enjoyable. She can go 3 turns where she can go left or right, and the probability of turning right the first time is 12, and the probability of turning right the second time is not 12, it's 1/2. Sorry, 1/2 and 2/3. Yeah. You can't have a probability of 12. It can only go up to 1. It's 1/2 and 2/3. Okay, so we're going to draw a tree diagram to represent the path, and so the probability of the first right was 1/2. The probability of the second right was 2/3. What is the probability she will turn left on the second turn? Well, if it's a 2/3 probability that she'll go right, 1/3, right? Because it's going to be, she can only go right or left, so it's 100% she'll go one way or the other. So it's 1/3. Yeah, it's boring, right? Okay, so the probability that she will go right and left, okay, because what is the probability that she's going to turn left the second time after turning right the first time? Okay, so we need to figure out right and left is going to be that 1/2 times 1/3, giving me 1/6. And the probability of a right followed by a left is 1/6 divided by 1/2, which is 1/6 times 2 over 1. Yep, and the 2 and the 6 both divide by 2. So she has 1/3 probability of going left, bless you, if she went right the first time, which is a 33.33% chance.